Hello students, in the past sessions we completed theories that were related to laws of motion, fine. So in this session we will do the PYQs that are related to that chapter, fine. So the stuff that we did see in the theory part were like Newtonian 3 laws. We completed all those 3 laws and application that were related to Newtonian laws, okay. So then we saw what is meant by friction, okay. So kinetic friction, static friction, rolling friction, we did see all those stuff, right. So finally we saw like the motion of car on a circular track and then the motion of car on a banked road, right. So these are the stuff that we did see in the theory part. Same way we also completed 4 different cases that were related to fictitious forces, okay. So you should be clear with all those concepts that we discussed over there. So by using those concepts we will be able to solve the PYQs, fine. So in this chapter it will be a little bit tricky to solve those sums, but once you get used with this chapter it will become easy, okay. So this is one of the foundation chapters in physics, so you should know this chapter clearly, right. Even though sums might be difficult for you to solve, still you will have to know all the theories that we did study in the theory part, okay. Fine, so let's jump into the question. Let's see the first one, right. So this is like an easy sum. Let's see what it is. The force F acting on a particle of mass m is indicated by the force time graph, okay. So they have given us the graph over here as shown. The change in momentum of the particle over the time interval from 0 to 8 seconds. So what I'm supposed to find is from the interval 0 to 8 seconds, I'll have to get the change in momentum, right? So generally, when they give you graph and they're asking us to find something, so one thing that has to strike your head, which is like finding the area under the graph, okay. So whenever we get the area under the graph, there is high possibility that we will end up getting the answer, fine. So in this situation, so it seems to be pretty obvious. We will find the area under the graph, okay. We would have done similar sum in the motion in a straight line chapter, okay. So in that situation, along the y-axis you will have the velocity and then along the x-axis you will have the time, right. So when you find the area under the graph you will end up getting the displacement. So same thing over here, okay, same logic, everything is the same. Only thing is we have changed the functions and parameters, okay. So along the y-axis you got forces, same way along the x-axis you got the time. So same time is along the x-axis, okay. So if that was the case, if I do the integration I'll end up getting the area under the graph, right. So let me integrate it. So if I do the integration in this situation, obviously I'll get the change in momentum. So this is like pretty obvious, easy stuff, right. So force F will be equal to change in momentum. So that's the formula for the force, right. So change in momentum divided by the time interval, okay. So vector stuff doesn't matter over here. So what I'm supposed to find here is the change in momentum. dp is something that I need to find, which will be equal to force time the time interval, okay. So if I do integrate it on the left and the right hand side, I'll end up getting the change in momentum. So in that particular interval, if the change in momentum was equal to del p, then obviously you will end up having force times force in that particular instant given by the change in time interval. That will give me the change in momentum, right. So in that particular time, how far the momentum has changed, that is something that I'll be able to get, right. So here let me do the area under the graph. Okay, so you should be clear with this one, which is like if you get the area under the graph on the first quadrant, which means above the x-axis, it has to be added, because in that case force is acting unfavorable to that of the motion of the car or the motion of that particular object. Therefore the change in momentum will be in an increment fashion, or it will be increasing, okay. So area under the graph above the x-axis has to be considered positive, okay, which means in the first quadrant. Then obviously the force that is acting on the fourth quadrant, which means on below the x-axis, it will obviously be negative, because it is not unfavorable to the direction of motion. It is actually acting opposite to that of the direction of motion. Therefore that will that will help in decreasing the momentum of the car, okay, or the motion of that particular particle, fine. So you should be clear with this stuff. Therefore, so if I do get the area under the graph for the first part, which means that's going to be like a triangle, obviously, right. So it should be like half into base into height, right. So for the base you'll get like 2 into height will be like 3. Got it? No, it's like 6. Okay, so if I do the multiplication, you have like 6. So from that triangle stuff, I got the change in momentum to be like 6 Newton meters. Okay, so the first triangle is done. Then another one positive parameter is actually this one. So you'll have like 4, 8. So that's going to be 4, and then 4 into 3, that will be like 12, right? So you'll have to consider only that interval. Therefore, it will be like 8 minus 4. So the interval is like 4. So you'll have like 4 into 3, which will be like 12. So this stuff is done. So I'll have to add these two things. That sums to 18. So these are the positive change in the momentum that I've got over here. Then I'll have to subtract it from the negative decrement that has caused because of the negative force. Okay. So that term will be like minus 3, and the interval is like 2. So 3 into 2, that's going to be like 6. So that will be like negative 6. Fine. So here the change in momentum will be like, so together you have got like 18. So 18 minus 6 will be like 12. The answer here is option 3. Fine. So the answer here is option 3. Right, you shouldn't have any doubt in the sum. So this is simple sum, right? So you have, only thing that you're going to do over here is finding the area under the graph, right? So here they have given us the force and then the time graph. So when you do the integration of force time graph, you will end up getting the change in momentum. That's what they're asking us to find. So just get the change in, just find the area under the graph, you'll get the answer. If the area was above the x-axis, which means on the first quadrant, you'll have to add it because it will help in the increment of the momentum. Same way, if it was below the x-axis, you'll have to subtract it, right? You shouldn't have any doubt in the sum. Let's move on to the next one. Next sum is, a stone is dropped from a height h. So you're dropping a stone from a height h, fine. It hits the ground with a certain momentum p. So when it reaches the ground, the momentum was equal to p, right? So the first statement is done. Then the second condition is, if the same stone is dropped from a height 100% more than the previous height. So in the second case, I'm going to drop it from a height that is equal to 2h, which means double the times of the initial height. Okay, so that is 100% more than the previous height, right? Obviously you should get this stuff. Then you have got like the momentum when it hits the ground will change by, so how does the momentum is going to change when with compared to that of the first situation? That's what they're asking us to find. Okay, the momentum when it hits the ground will change by what percentage? That's what I need to find. Okay, so what I'm supposed to find over here is actually, so in the first situation, when I dropped from certain height h, it reached the ground with the momentum p. Okay, in the second case, I just dropped it from double the height. So how does it actually increase with respect to the first situation? That's what they're asking us to find. Okay, so how does the momentum change when it reaches the ground? How far the momentum will change when it is going to reach the ground in the case of the second condition? That's what I need to find over here. Okay, so you should be clear with this stuff. So what they're asking us to find is actually how far it is going to increase in the second case considering the first situation. Okay, so they're asking us to find the percentage. So what was the change? That will be like the second case momentum minus the momentum in the first case. Okay, divided, I'm just going to compare it with the first case, therefore I'll divide it by the first initial momentum or the first situation momentum, which will be like the p. Okay, it's same thing like finding the percentage, how far it has increased with compared to the first situation or the initial situation. So here you have got like two different situations, therefore I'm just going to compare it with the first situation, right? So obviously this is how I'll do the comparison, right? This is how I'll just be able to compare it with the initial condition. So all those things, it is just the same logic into it, right? You shouldn't have any doubt. And then they're asking us to find the percentage, right? So it will be like into 100. As it is like finding the percentage, I'll just multiply it with 100, right? So this is what I need to find here. Fine. So in the initial situation, if I need to get the momentum, that is like pretty obvious. You'll have like p, which is equal to, what will be the momentum change over here? So I'm just going to drop it from the height h. So obviously you'll have like p, which is equal to m times the final velocity v. So if I need to get the final velocity v, if I'm just going to drop it from certain height h, I'm just not going to throw it, I'm just going to drop it. So your initial velocity will be like 0, right? So if I get the third kinematic equation, v square minus u square, which is equal to 2as. If I'm just going to use that kinematic equation, we have already done this stuff in the motion straight line chapter itself, so you should be clear. So the final velocity v will be equal to root 2 gh, right? Got it? No doubt, right? So initial velocity was like 0, therefore the final velocity will be like root 2 gh. I've just used the third kinematic equation. Okay, it should be clear. Therefore you will have like p m root 2 gh. So that will be the increment in momentum or the final momentum which I had in that particular stone in the first situation. Okay, so this stuff is done. So now I have found the p. what I need to find here is the momentum change. I mean, what was the momentum in the second situation? Okay, so from that I'll be able to get the change in momentum with respect to the first condition. Okay, so that thing is obviously if I substitute the p dash over here, I'll end up getting that stuff. Therefore, for the second situation, you will have something like this: p dash, which will be equal to m times the v, final velocity v. So instead of v, what I need to put here is actually the 2h, okay, because it is like double the times of h compared to that of the initial situation, 100% more than the previous condition, which means I'll have to add extra 1h to the initial condition. That's what is meant by 100% more, right? If it was like 50% more, that will be like 1 plus 0.5, that will give me like 1.5. Here it is like 1 plus 1, so that is like double the times, right? So you will have 2g into 2h, which will be like 4gh, right? You should be clear with this stuff. Now let me do the subtraction and I'll just plug in all those parameters into it. You'll end up getting the answer. So you will have p dash m root 4gh minus m root 2gh divided by, you will have like m root 2gh, right, into 100. Obviously I'll be able to cancel out the same stuff, right? So what is the same stuff in the numerator and the denominator? You'll have like m root 2gh. Those two things is going to be same. Therefore I'm just going to factor out m root 2gh. If I do factor out that stuff, you will have something like root 2 minus 1 into 100 divided by m root 2gh, right? Obviously these two stuff will get cancelled out, and then only parameter that you are left with will be like root 2 minus 1, that will be 1.414 minus 1, that's going to be like 0.41 into 100 percentage, which will give me like 41 percentage. So the answer here is option 2, right? So you should be clear with this sum, right? So this is more kind of a statement based sum, right? So they have given you like two different condition. In the first condition, I dropped it from certain height. In the second condition, I just dropped it from double the time of that height. So if I do subtract those two things, I'll end up getting that change in momentum with compared to that of the initial situation. If I just divide it, I'll end up getting that stuff. If I just multiply it by 100, I'll get it in percentage. That's it, right? So you should be clear with this sum. So this is easy sum, right? You shouldn't have any doubt in the sum. Let's move on to the next one. Next sum is a body under the action of force vector F, which is equal to 6i cap minus 8j cap plus 10k cap. Okay, so that is a force that is acting on a body, and then they have given us the force in vector itself, right? Acquires an acceleration of 1 meter per second square. The mass of this body must be. So I need to get the mass of this particular body, and then they have also given us it acquires an acceleration of 1 meter per second square. So that stuff is also done. Okay. So if I need to get the mass, so what is the formula for the force, mass and acceleration? It is obviously F, which is equal to ma. Got it? So they are asking us to find the mass, which is a scalar quantity. Okay. So m is actually a scalar quantity. But if you see the question, they have given us the acceleration in terms of scalar quantity. Okay, so that is given in scalar itself. M is a scalar quantity which I need to find. So acceleration is obviously vector quantity, but they've given us the magnitude itself straight away. Acquires an acceleration of 1 meter per second square, which means the direction doesn't matter over here. Okay, so they have given us in terms of scalar itself. Only thing is the force is given in vector quantity. Okay, so I'll have to get the scalar quantity from this vector quantity, which means if I just find the magnitude for this particular force and I substitute it over here, I'll obviously get the mass. Okay, so pretty easy and obvious thing. Okay, so let me do it. So you will end up having, I'm just going to take the magnitude for the force. So you will have vector F and its modulus, which will be equal to root of 6 I cap, so that will be like 6 square plus 8 square, negative 8 square, which is going to be positive again, and then you'll have like 10 square. Okay, so you will obviously have 36 plus 64, that gives you 100. Okay, and then you got one more 100, so altogether you will end up having root 200. So if I just take the value out of the root, you'll have like 10 root 2. That will be my answer. So the answer here is option 3, right? So this is easy sum, right? You shouldn't have any doubt. Let's move to the next one. This sum is kind of easy, but the only thing is you'll have to have conceptual understanding to the sum, right? Let's see what the sum is. Sand is being dropped on a conveyor belt at the rate of m kg per second, okay? So you are having a conveyor belt which is carrying some material. In the situation, that particle is like sand, okay? That object is like sand, okay? Which means your conveyor belt is something that you should have known. So you'll have like two rollers and then you're going to have a sheet above it. From this, this roller will constantly keep on spinning, which will carry the weight that is placed over it, okay? So obviously this roller is going to spin with a constant velocity, okay? So when it is going to spin with a constant velocity, I'm just going to add object to it. That object is actually sand over here, okay? So this is a conveyor belt in a factory or something like that, okay? So you got like sand is being dropped on a conveyor belt at the rate of m kg per second. So mass is something that I'm adding into it. So the variable parameter over here will be like mass, okay? The force necessary to keep the belt moving with a constant velocity of v meter per second, okay? So here the velocity of the conveyor belt is same, but only thing is that entire setup is getting added with the extra masses, okay? So here mass is going to change, so that will be the variable parameter, where in the case of velocity that's a constant thing, okay? So this stuff is not going to accelerate, or the velocity of the conveyor belt is not going to increase. Only thing is mass is getting added at a constant rate, and then the entire belt is moving with the constant velocity, okay? So in order to keep the constant velocity, I'll have to actually give in the force, right? So let us imagine this way. You are having something, a toy car or whatever it is traveling with the speed of 2 meter per second, okay? And then I'm just going to put load into it. Obviously the entire mass is going to increase, therefore the velocity will decrease accordingly, right? So same thing is happening over here, but the stuff is I'm just going to keep it with a constant velocity. So if I have to keep it with a constant velocity, I will obviously have to give an extra force to it. So what is the force that I need to give? That's what I need to find it over here, okay? Fine. So I'll just find the force from its parent equation itself, which is like vector F, that will be equal to vector F, which will be equal to change in momentum divided by the time interval, okay? So generally in majority of the situation, when you are going to consider a constant mass will be a constant parameter, but in the situation mass is not a constant parameter. In turn, velocity is actually a constant parameter, okay? So let me do the differentiation. So before doing the differentiation, I'll just write one more step into it, which is like differential of mass times velocity divided by the time interval, okay? So if I do the differentiation over here, obviously you should know the stuff here. Mass is the variable parameter. Generally in majority of the situation, velocity will also be a variable parameter, okay? So here I'm just going to generalize it, which means I'll just consider those two stuff, mass and velocity, to be the variable parameter. Then in the second step, I'll just put velocity to be a constant one, okay? As these two parameters are variable over here, I'll have to use like UV method, right? So I should have taught you in the motion as straight line chapter while doing differentiation. I have told you that formula, okay? So UV, what you'll have to do is first you'll have to consider one term to be like constant. I'll differentiate the second one, then I'll just add, and then I'll take the second term to be like constant, and I'll differentiate the first term, okay? So you should know that UV method, right? From the math classes you should have known, but the stuff is, this is like a simple one, right? Let me do it, we'll get it anyway, okay? So if I differentiate this stuff considering these two parameters to be like variables, then first what I will do is, this is a kind of multiplication stuff, okay? So if it was in such fashion, then what I will do is I'll first differentiate. First I'll place the first one as like constant, then I'll differentiate the second term, whatever it is. So mass is constant, same way, and then the velocity will change, right? D vector V divided by dt. So this is the general force formula that we end up getting. And then the second term will be like velocity V will be constant, okay? So V is going to be constant, but in the case of mass, that's going to change, dm divided by dt, okay? So this is how we'll have, okay? So this is how obviously it's going to be. So here obviously velocity is not going to change. The conveyor belt is going to move with a constant acceleration. Therefore, this term goes to 0. Okay, because you do not have change in velocity, which means you will not have acceleration in that conveyor belt. So the first term goes to 0. So force here will be equal to m. So the force here will be equal to v dm divided by dt. Okay, I'm just worried only about the magnitude. Okay, so here the vector doesn't come into picture. Okay, obviously this is going to move in one dimensional, so vector stuff doesn't come into picture. So v dm divided by dt, so at what rate I'm just going to drop the mass into it, that will determine the force that I need to give to that particular object. Okay, so for example, if I'm just going to put in 1 kg per second, so I'm just going to add 1 kg per second and the velocity of the belt was like 5 meter per second, then I'll have to constantly give in 5 Newton force. That's what this represents. Okay, so here at what rate I'm actually adding the mass, that's what I need to find. So if I just see the question, the rate of mass that is being added is actually m kgs per second. So if it was like 1 kg per second, so and the velocity was like 5, it will be like 5 Newton. If the mass that I'm going to add is like 2 kg per second, so then it will be like 10 Newton, obviously, right? So in this situation, they haven't given any magnitude or value to it. They have just given it as a variable, which is like capital M. Therefore, I'll just put in the capital M straight away. So you'll have the force that I need to give to that object will be like capital M, the mass at what rate it is getting added times the velocity v. Okay, so the answer here is mv Newton, which is like option 3, right? You should be able to understand this one, right? You shouldn't have any doubt in this sum. So this is more kind of a logic based sum, right? So I'm just going to put in the mass. So mass will be the variable parameter. Just take the parent equation, just like force, which is equal to change in momentum by the time interval. Do the differentiation using the AB method, you'll end up getting the answer, right? You shouldn't have doubt in this sum. Let's move on to the next one. Next sum is an object of mass 3 kg is at rest. Okay, so the initial velocity of that object is 0, fine. Now a force capital F, which is equal to 6t square I cap and 4t j cap, which means they have given us the force in terms of vector quantity is applied on the object. So initially it was at rest, and then I'm just going to give a force to it, to that particular object. Then the velocity of the object at t equals 3 seconds. So what will be the velocity of that particular object when the time was equal to 3 seconds? So if you just look at the option, it is pretty obvious. They are asking us to find the final velocity in terms of vectors, okay, not in terms of magnitude. So you just need not take that square root and all those stuff. Okay, so here from force I'll be able to get the acceleration because F equals ma. So they have given us the mass also, so from that I'll end up getting the acceleration. Acceleration is nothing but the change in velocity divided by the time interval. Okay, so initial velocity was like 0, so if I end up getting the change in velocity, if I do the integration, I'll end up getting the change in velocity. From that I'll be able to get the final velocity. Okay, so simple step, just do the integration, you'll get the answer, right? So it is easy. When I do solve it, you'll get it. So you have like force, which is equal to mass times the acceleration. Everything is in vector, therefore vector F equals m vector A. Okay. So here for the mass, I just need to plug in like 3 kg. That's what I need to plug in over here, right? So for the mass, you'll have like 3 substituted over there. And then I just need to get the acceleration, right? So acceleration A will be equal to, 6t square I cap plus 4t j cap, right? So I'll have to divide it by 3 to get the acceleration from the first. So you'll have like, if I divide it by 3, you'll have like 2t square I cap 6 divided by 3, that's going to be like 2 plus 4 by 3 t j cap. Okay, so now I have got the acceleration. So then you have the next step, which is like vector A, that will be equal to change in velocity divided by the time interval. Okay, obvious. So from this it will be pretty clear. Change in velocity will be equal to a dt. Okay, so if I do integrate this one, I'll get the final velocity, right? So the initial velocity, if I, while doing integration, I'll have to substitute the limits, right? So here I'll substitute the limit for the time. So the initial time will be like 0 and the final time will be like 3 seconds. Okay, same way here, initial velocity will be like 0, so that will be the starting condition, so that will be the lower limit, and the upper limit is the final velocity that I'm supposed to find over here, right? So if I do the integration of the left hand side, you will end up getting the final velocity. Obviously the initial velocity, which is the lower limit over here, is actually 0. Okay, so this term goes to the final velocity, which is like v. Same way, if I do the integration over here, I'll just get the velocity, the required velocity that I'm supposed to find. Okay, so obviously I'll substitute it here in terms of vector itself, and they are asking us to find in terms of vector itself. The answer is also supposed to be find in the vector. Okay, so if they're asking you to find the magnitude, just do the same step what I'm doing over here. Finally you'll have to take the square root stuff and then end up getting the magnitude. Okay, so here just do the integration, you'll get the answer. left hand side, it is like pretty obvious. The initial velocity was like 0, final velocity is the thing that we need to find, which is going to be like v. Here, over here you have like initial limit, that's going to be like 0 starting time, and the final time for which I need to find the velocity was like 3 seconds. Okay, so let me plug in 3 for the upper limit. You will have velocity v which is equal to vector a dt, right? So do the integration, will end up getting the answer. So 0 to 3, and then for the vector a you will have 2t square I cap plus 4 by 3 t j cap, and then you have like dt. Okay, let me do the integration, you'll get the answer. So if I do the integration, so obviously this is in addition. Okay, so treat the first term as separate term and treat the second one as the next term. Okay, so first I'll integrate the I component, then I'll integrate the j component. Okay, so if I do the integration, I'll change the elongated s to square bracket, so we'll have square bracket. So if we do the integration for the 2t square, it's going to be like x plus n plus 1, x to the power n plus 1 divided by n plus 1. Therefore you'll have like 2 power n plus 1 will be like t cube divided by 3. Got it? Yeah. I cap plus 4 by 3 t j cap, which will be like n plus 1 divided by n plus 1. That's going to be like t square and then divided by 2. Okay, so 4 and 2 will get cancelled out, and then in the numerator you'll have like 2, and then in the denominator you'll have like 3. Okay, I just cancel it off straight away, so we'll have like j cap. Yeah, then let us put the power, we'll end up getting the answer. Okay, so let me substitute the limits into it, we'll end up getting the answer. Okay, so here v will be equal to 2, okay, into, you'll have like 27. Okay, 3 into 3 into 3, so 1 3 will get cancelled out, so we'll have like 2 into 9 I cap plus, yeah, plus you got like 2 1, you'll have like only 1 3, other 3 will get cancelled out, so we'll have like 6 j cap. Okay, so the answer here is 18 I cap plus 6 j cap. 18 I cap plus 6 j cap, which is like option 2. Fine, so you should get this one, right? You shouldn't have any doubt. So the first option is like 3 I cap. Okay, so 18 I cap and then 6 j cap, which is like option 2, right? You should be clear with this sum, right? Straight away we did the integration to get the answer, but the only different thing that we did over here is actually we integrated I component separately and then the j component separately. So whenever you get like vectors while doing the integrations, you'll have to do the same stuff again, but the thing is treat the I component as a separate term and then the j component as a separate term. Generally when you have 2 3 different terms, I'll just treat everything as a separate term, right? You will have to do the same thing over here also, right? You shouldn't have any doubt in the sum, it should be clear. Let's move on to the next one. Next sum is a cricketer catches a ball of mass 150 gram in 0.1 seconds moving with the speed of 20 meter per second, then he experiences a force of, okay, so here what I need to find is the force experienced by the cricketer in his hand. Okay, so obviously forces are equal and then opposite, so whatever effect that I gave it to the ball, I'll end up experiencing the same effect, right? So that's obviously the Newton's third law. I would have already told you while doing the Newton in 3 laws. Okay, so while doing the second law, I've just told you like how far the force that I need to give to stop that particular ball, right? So same understanding over here. Fine. So I have got like mass to be like 150 gram, and then I brought it to rest in 0.1 second, which was moving at a speed of 20 meter per second. Then what should be the force that the person should have given to that ball? That's what I need to find. Okay, so obviously force will be like equal and then the opposite. Therefore, the negative sign doesn't play any role. Just get the magnitude, you'll end up getting the answer over here. Okay, so force here will be like what is the force actually here? Mass times the acceleration. Okay, so the mass will be like 150 gram, so I'll have to convert it to the kg, which will be like 0.15 kg times the acceleration, which will be like final velocity minus the initial velocity, right? So 20 minus 0, that's going to be like 20. Same thing divided by 0.1. If I do the solving step, you'll have like 20 divided by 0.1, so it will be like 1 by 10 here. So if it will just get multiplied to the numerator, right? So you'll have like 200 in the numerator, 200 times 0.15, right? So 200 times 0.15 will be like 2 into 15. Obviously, if I move the decimal places, it will be like 2 into 15, which will be like 30, right? So the answer here is like option 2, right? So this is like simple sum, right? You shouldn't have any doubt. Let's move to the next one. Next is sum is a rigid ball of mass m strikes a rigid wall at 60-degree. Fine. So they have given us the picture clearly over here. So there is a mass m, which is a ball that is going to strike a wall at an angle of 60-degree, right? So they have clearly given the angle, orientation, and everything. Okay, and gets reflected without loss of speed as shown in the figure. So it hits and then it bounces back with the same angle 60-degree, and it is given pretty obvious, pretty clearly in the diagram itself. Okay, so and gets reflected without loss of speed as shown in the figure, right? So that will be the final velocity. The value of impulse imparted by the wall on the ball will be. So what I need to find here is the impulse on that ball, which means the change in momentum of that particular ball. Okay, so impulse is something that we have seen in the theory part itself. So impulse actually means change in momentum that is happening at a quicker speed, which means at a shorter interval. Okay, so if it was very quick, then I'll call it as impulse. Okay, so when something is going to hit and then when it bounces back, it will happen within a fraction of second. So if that was the case, then that is called as impulse. Okay, so the only thing is you have like two different terms, but solving everything will be just the same thing. Okay, so what they're asking us to find is the change in momentum of that particular ball. That's what I need to find. Okay, so they have given pretty obviously everything that is needed, which is like the velocity, direction of the velocity, angle, and everything is given over here. So only thing that I need to find here is the final momentum minus the initial momentum. Okay, that will give me the change in momentum. Okay, so del p will be my change in momentum. That will be equal to vector final momentum minus the vector of initial momentum. Okay, got it? It should be clear. Fine. So to get the vectorial representation of the momentum, what I need to do is I'll have to split the velocity into two components, okay, along the x and then along the y. Okay, so here let me split it this way. This will be my x and this will be my y. Okay, so if you look at the angle, it is pretty obvious. These two are alternate angles, right? So it is inside the shape is z. Okay, therefore these two things are alternate angles. Okay, so if that was the case, then obviously this should be 60-degree. Okay, so if this was 60-degree, then obviously that will be my cosine component, which is like x. So it will be like mv cosine 60-degree. This stuff is done. Same way this will be like mv sine 60-degree. So this stuff is also done. Okay, so then you have got like the final momentum that I need to find over here. Okay, so the final momentum will be this kind of splitting, which will be something like this. You will have this component to be my x component, which will again be directed downwards, and then you'll have like this one to be my, I mean this one will be like y component, which will be directed downwards, and then the x component will be opposite to that of the initial momentum direction. Okay, so here first let me plug in the 60-degree. Where should I put actually? So this was 60-degree. Okay, then obviously these two angles will be same because those two things are like alternate angles. So those two stuff has to be same, which will be like 60-degree over here. Okay, so this angle should obviously be 60-degree. Okay, so then what should be the horizontal one? That will be like mv cosine 60-degree, pretty obvious. So this one will be like mv sine 60-degree. So x component matched with the cosine component, same way the y component matched with the sine component in this case. Okay, got it? You shouldn't have a doubt in this case. It should be clear. Now let me plug in the vector into it. Okay, so here you have got mv cosine 60-degree that is directed towards the right side, so it will be like I cap. Okay, this will be like minus j cap, pretty obvious. So if you consider this situation here, obviously even in the final momentum the velocity was directed downwards, therefore that's going to be like minus j cap. Okay, so this component is opposite to that of the initial momentum. So initial was like positive, then obviously this should be like negative. Okay, so this component will be like negative I cap. Okay, so now what I need to find is I've just got all those vectorial component that is needed. What I need to do is I'll have to subtract the final vector minus the initial vector. When you look at this stuff, it seems to be pretty obvious that the y component will get cancelled out because I'm just going to subtract it, okay? So these two are in the same direction, therefore those two things will get cancelled out. Then obviously the x component will get added because those two are of opposite signs. So when you do the negative thing, final minus the initial, when you're going to subtract it, it will get added, right? So let me do the solving, you'll get it, okay? So first let me plug in the initial momentum, I mean the final momentum. So the final momentum will be mv cosine 60 degree minus I cap, and then you will have plus mv sine 60 degree minus j cap. Okay, so this part is done. So that will be my final momentum minus of the initial momentum. Initial momentum which will be like negative of the initial momentum. So when you do look at the initial momentum, so the first term becomes negative, right? So you'll have like minus mv cosine 60 degree I cap, and then one more negative sign to this y component, so that becomes positive. So you'll have like plus mv sine 60 degree j cap, so that becomes positive, right? Negative negative becomes positive. So I have multiplied this complete term by negative, and after doing the inner multiplication I just wrote it straight away. Okay, so when you look at this stuff, it is pretty obvious. This one is like negative, the first one, the other one is like positive, so those two y component will get cancelled out, these two stuff will get added. So you will have minus 2 mv, you will have negative of 2 mv cosine 60 degree. Okay, so what will be the cosine 60 degree? So cosine 60 degree will be like 1 by 2, right? So that will be like 1 by 2 I cap. Got it? So those two stuff will get cancelled out. So 2 will get cancelled out, and then you will just be left with negative of mv. Fine. So when you look at the option, what they're asking is to find is the value of impulse imparted. So by the term value, what they're asking is, what they're telling us is actually to find the magnitude of impulse. Okay, so if they've given you the negative sign, then obviously minus mv will be the best choice over here. But the thing is, they didn't confuse us, they have just taken out this negative sign from all those options. So therefore it is pretty obvious mv should be my answer. Okay, so because they are asking us to find the value of impulse, which means the magnitude, that's what they're asking us to find. Okay, so obviously in this entire setup, the value of impulse imparted by the wall on the ball. So I have just found the change in momentum of the ball. Okay, so obviously that should be like negative of mv, but in this case I'm just going to mark the answer based on the magnitude, therefore it should be like option 1, right? So you shouldn't have any doubt in the sum, right? So this is like pretty obvious sum, but thing is you'll have to correctly match those thetas. Okay, those angles, opposite angles and alternate angles has to be found out properly, and then it has to be matched. Then I'll have to just do the difference between the final momentum and then the initial momentum. You'll end up getting the answer, right? No doubt should be there, it should be clear. Let's move on to the next one. This sum is also similar to that of the previous sum. So you have got a body of mass capital M hits normally a rigid wall with a velocity v. Okay, so there is a mass which is traveling normally, and then it hits the wall with a velocity capital V and bounces back with the same velocity. Okay, so it hits and then it bounces back with the same velocity. The impulse experienced by the body is, so what will be the impulse, which means what will be the change in velocity experienced by that particular body or particle. That's what I need to find. Okay, so same as that of the previous sum, but the thing is this is like super easy when compared to that of the previous sum. Okay, so here you have got a particle that is going to hit the object normally. Okay, so the initial mass was like m and then the velocity was like v, therefore so the initial momentum will be like mv I cap. Okay, and bounces back with the same velocity and same direction. So whenever it is going to hit normally, then obviously it will bounces back in the same line itself. Okay, so it's a kind of one dimensional motion, therefore no vector, those stuff doesn't come into picture. Okay, so here it hits and then it bounces back in the same line itself, therefore you will have the final velocity to be like m minus mv or mv minus I cap. Okay, mv minus I cap. So this stuff is done, right? So what I need to find is the impulse experienced by the body is, which means I need to get the change in momentum, right? So change in momentum will be like final momentum minus the initial momentum. So my final will be like negative mv, initial will be like mv, negative of mv, so it will be like those two things will get added up obviously, so we'll have like minus 2 mv, and then I have arbitrarily taken it to be in the x direction. Okay, it could be in any direction, that doesn't matter. They have just given us the question bluntly, therefore direction doesn't matter. Okay, so you'll have, in the situation you will end up getting minus 2 mv I care. Okay, so the change in momentum over here that has been experienced by the ball will have a magnitude of 2 mv. Okay, that's the thing that they're asking us to find. So the answer here is option 3, right? So we shouldn't have doubt. So this is same like a previous sum, but the only thing is this is extra more easy. That's it, finished. Okay, we are just considering only one axis, it's a kind of x direction alone. Okay, you shouldn't have doubt in this sum. Let's move to the next one. Next sum is from the logic that we have seen in the projectile motion. Okay, so everything that whatever we solve will be similar to that of the motion in a plane chapter. Okay, only thing is here I'm just going to find the momentum, therefore I'll just plug in extra m to it. Okay, so instead of velocity, that's how we did projectile motion sum and everything in the last chapter, but in this chapter the sum solving method, everything will be similar to that of the projectile motion, but the only stuff is I'm just going to find the momentum, therefore I'll multiply m to it. Okay, let's see what the sum is. Simple sum. You have got a particle of mass m is projected with velocity v, making an angle 45 degree with the horizontal. Okay, so at an angle of 45 degree I'm just going to throw it. When the particle lands on the level ground, the magnitude of change in its momentum will be. Okay, so what I need to find here is the change in momentum, which means final momentum minus the initial momentum. So those two endpoints will be like the landing point minus the starting point from where it got projected. Okay, fine. So let me draw the diagram, we'll get it straight away. Easy sum. So here I have got, this is the land surface, so I'm just going to project at an angle b. Okay, so I mean with the velocity v making an angle 45 degree. Okay, obviously what will happen to this particular object, it will move in a projectile motion and then it will hit the ground at an angle of 45 degree, same 45 degree. Yeah, right. Okay, so the only component that would have changed will be my y component, x will be the same, right? So this x component will be the same thing, only thing that would have changed will be my y component. So you will end up having the same y component, but the thing is the direction will get reversed. Fine. So here, so this angle will be 45 degree, right? So what they're asking us to find is when the particle lands on the level ground, the magnitude of change in momentum will be. So I need to find the change in momentum, which means like final momentum minus the initial momentum. So let me do it. So here you have got this component, which will be my x, and this will be my y, correct? So x component will be like v cosine 45 degree I cap. Okay, so here also you will have same v cosine 45 degree I cap. It is pretty obvious that the x component is not going to change, only the y component will change in its direction, right? So here the y component will be v sine 45 degree, that will be like plus j cap. Here in the situation it will be like obviously v sine 45 degree minus j cap. Okay, so what they're asking us to find is the magnitude of change in momentum will be. So when the particle lands on the level ground. Okay, so when it lands on the level ground with respect to the initial momentum, how far it has changed. Final momentum minus the initial momentum. So if I do the final momentum minus the initial momentum, obviously I component will get cancelled out, right? So final minus initial, so this one will be like positive, this one will be like negative, therefore these two components will get cancelled out, obviously, right? We have done it multiple times. Same way, when you look at this component, it will be like negative, and this one will also become negative. Okay, negative negative, it gets added up negatively, and then you will have the answer, right? So final change in momentum, I'll just put it straight away. You'll have like change in momentum, which will be like negative momentum, therefore I'll have to multiply mass to it minus mv. Sine 45 degree will be like 1 by root 2, so that will be like 1 by root 2, and then j cap. Yeah, okay, so as it got added, right, so there will be like two terms into it, right? Minus mv 1 by root 2 j cap, and then another one minus mv, so you should put like 2 before it, so we'll have like 1 more 2. in front of it. Got it? It should be clear. Just do the addition of these two stuff. We'll end up getting this one. So the final answer will be like root 2 mv, negative root 2 mv. But here also, the only thing that I'm worried about is the magnitude. Therefore, it will be like root 2 mv or mv root 2, which is like option 1. Fine. So easy sum. The same sum as that of the sums that we have seen in the motion map plane chapter. But the thing is, I've just plugged in extra m to it because they have asked us to find the momentum. Okay. You shouldn't have any doubt in the sum. Let's move on to the next one. That will be the final sum for this session. This sum is a 0.5 kg ball moving with a speed of 12 meter per second strikes a hard wall at an angle of 30 degree with the wall. Okay. So they have given us some statement. So based on those statement, let me draw the diagram. Okay. So here what we have is you're just having a wall. Okay. And then a 0.5 kg mass ball moving with the speed of 12 meter per second strikes a hard wall at an angle of 30 degree with the wall. Okay, so not with respect to the normal of the wall. With the wall, it is going to hit at an angle of 30 degree. Okay, so here this is how it just goes. It hits this one. Okay, same way this angle will be like 30 degree. So they have given you this angle to be 30 degree. Okay, then what happens is it is reflected with the same speed at the same angle. Okay, which means so same thing is going to repeat. So it just gets reflected at the same angle, which means same way this will be like 30 degree. Okay, got it? Fine. If the ball is in contact with the wall for 0.25 seconds, so it is in contact for 0.25 seconds, fine. The average force acting on the wall is, so what will be the force that is acting on the wall, which means whatever force that the ball experienced, same amount of force the wall would have experienced. Okay, so what they're asking us to find is just the force, and obviously they're asking us to find the magnitude of the force, right? So do not worry about those negative sign. It is pretty obvious from the option. They're just worried, they're just asking us to find the magnitude. So I've just drawn a setup over here based on the imagination. Either the ball could have hit it on the right side or it could have hit it on its left side, whatever it is. But in the situation, I'm just drawing it in such a fashion that the ball is moving towards the right. The other way around is also possible. It could have hit the wall on the other side also. That too is possible. So negative sign doesn't come into picture. Only thing is I'll have to put all those negative sign and solve it. Finally, I'll have to get the magnitude and I'll have to mark it. Okay, so it is obvious. So here we obviously know from the previous sums that we have seen, the y component will get cancelled out. Only thing that I'm worried about is the x component. Okay, so let me do the solving for x component. I'll end up getting the final momentum. Okay, I mean change in momentum. Okay, so initial momentum along the x direction. Okay, so this one, initial momentum along the x direction. What should this one be? So if this angle was like 30 degree, then obviously we know this angle will be like 60 degree, right? If I just put an z something like this, okay, so this angle will be my alternate angle for this 30 degree. If this was 30 degree, then obviously this should be 60 degree. This is something that we have already seen. Therefore, this angle will be like 60 degree. Okay, it should be clear. So here, the momentum along the x, okay, initial momentum along the x will be like 0.5. Okay, anyway, mass times the velocity, and that component will be like the cosine component, right? So the cosine component 60 degree, cosine 60 degree will be like 1 by 2, therefore mb 1 by 2. Okay, this will be directed towards plus I cap. Okay, so same thing is going to happen along the, so you'll end up having the same momentum on the x for the final. Only thing is the direction would have flipped, right? Obviously, this is something that we already know. So the final momentum will be something like this. You will have the final momentum along the x will be something like this, m v 1 by 2, but this will be directed towards the minus I cap. Okay, so these two stuff will get added. Obviously, when you do the change in momentum, final minus initial, these two stuff, this final component and the initial will get added, and then you'll have negative sign. Same way, y component will get cancelled out because those two are in the same direction, and then we are going to subtract it. Therefore, those two things will get cancelled out, right? Okay, so here change in momentum del p will be equal to, I'll just have to add these two stuff. So you'll have negative of m v 1 by 2 plus negative of mb 1 by 2. So when those two things get added, 2 will get cancelled out, and then you'll just be left with negative of mb. Okay, just put in the mass and then the velocity. Fine. So mass will be like 0.5. Do not worry about the signs, just leave it 0.5 into 12. So that will give me the change in momentum. What I need to find is the average force acting on the wall or ball. Both those things will be in opposite direction, but it will have the same magnitude. So whatever it is, force will be equal to change in momentum divided by the time interval. So it will be like 0.5 into 12 divided by 0.25. Okay, so 0.25 and 0.5, when those two stuff get cancelled out, you'll have like 2 in the numerator. So 2 into 12, that's going to be like 24 Newton. So the answer here is option 3, which is like 24 Newton. Fine. You shouldn't have any doubt in the sum. So this is same as that of the previous sums that we have seen, right? So you should be clear with all those 10 sums that we have seen in this session. So the sums were mainly related to the change in momentum and those stuff, okay? And then we did also see like change in momentum area under the graph and all those things, okay? So you shouldn't have any doubt in this session. It should be clear. So we need around like 5 sessions to complete this entire PYQ, okay? So you get around like 55 sums, okay? So in like around like 5 sessions, I'll be able to do all those PYQs that are necessary, okay? You shouldn't have any doubt in the sums that we have seen, okay? So with this, the video gets completed. Bye.